Hello guys, welcome back to our channel. Today we're gonna discuss about representing knowledge using rules. So this is the artificial intelligence lecture series video number 20. So here we're gonna discuss about the knowledge representation of artificial intelligence and the traditional tools also. So we'll go forward. So it deals with how information, facts, relations and rules about the real world can be represented in the form that a computer system can understand, reason about and use to make intelligent decisions. So this is the definition for representing knowledge using rules. So it basically sets a rules for the knowledge which was being provided by us, and based on that it will give the system will make the decisions and it will give better decisions than us. So what is knowledge representation? In artificial intelligence, so knowledge representation refers to the method used to encode knowledge into a machine so that it can be processed logically. Whatever the information we took, it will process logically. This knowledge may include facts, concepts, rules and relations and heuristics about a problem domain. It can have all these things, facts, concepts, all these things. The main goal of knowledge representation is not just storing information but also enabling reasoning, inference and decision making. The main goal is not only getting the final thing, final output. It will do reasoning, it will do inference and it will do better decision making also. The general problem of efficient knowledge representation will go forward and we'll learn more about it. So in computer science, one of the major challenges is to represent knowledge efficiently. Whatever the knowledge we have, you have to show it efficiently. So in order to do that, we have to be easy. Whatever the data we have, it should be easy and understandable, and it can be modified also. So we have to support logical reasoning and inference. We have to support it, or else we can't make any better decisions. So be computationally efficient. Computationally efficient. If you work on a large amount of data, it is very important to be efficient computationally, as it requires more of computational power, and then capture real world complexity accurately. You have to put a real world example so it can the machine can understand betterly. Okay. And then unlike traditional programming, artificial intelligence systems must deal with uncertainty, incomplete information and the complex relations. So the whatever the information which is provided by us, it can be, we can't rely on that, and the information might not be true, it might be incomplete, it can be complex also. It will be very hard for us to understand. If it is for traditional programming, it can be done, but for using artificial intelligence, you can choose you can get by the information you have given. Hence, choosing the right representation method is critical. So what comes under knowledge representation? So we're going to compare knowledge representation and basic data structures. In traditional computer science, we use basic data structures such as arrays, linked list, queues. These are the basic data structures we're going to use, and then we're going to use recording structures as well. So here the data structures are excellent for storing and retrieving data. However, they do not capture meaning or relations between pieces of information. It is very important to know that the data structures here, they do not capture meaning or relations. They don't do anything like that. Okay. So it completely depends on the information which we are giving, and if the information which we are giving is wrong, then it won't find any facts. But here knowledge representation goes beyond simple storage. So here we use meanings, relation between concepts, rules for reasoning. This is best according to us. I'll tell you an examples as well. So here, for example, an array can store values, but it cannot express a rule like if it is raining then the ground is wet. So you guys are understanding it, right? Yeah. So that is the example. So AI specific knowledge structures. So artificial intelligence uses specialized structures to represent knowledge efficiently. Some of the important ones include, see, these are the list which comes under this. So list representation. Lists are one of the simplest and most widely used knowledge structures in AI. Then especially in languages like LISP, they allow flexible representation of symbols, facts and hierarchical information. In this is the most widely used knowledge structure. Here it takes symbols, facts and hierarchical information. And next we have logic and predicate calculus. So here logic based representation use formal logic to represent facts and relations. Predicate logic allows statements with variables, enabling more expressive representation. For example, if you give human Socrates, then it will state whether the given condition is true or not. Okay, and the third one is rule based representation. So typically it works like this: if condition, then action or conclusion. That's it. It will use if when we have to use condition, or else then when we have to do any action or conclusion, direct conclusion. Rule based systems are widely used in expert systems and decision making applications. Okay, then we have semantic networks. So this network represents knowledge as graph consisting of nodes and links. Like a main node will be there and links will be there. Okay, nodes represent concepts and links represented relations. So frames represent knowledge using structured objects with slots and value. They are useful for representing stereotypical situations. Okay, then we have clips. It is a rule based programming language developed by NASA. It is used for building expert systems and support facts, rules and inference mechanisms. Okay, it was developed by NASA. And then types of knowledge in AI. At the end, let us briefly look at the different kinds of knowledge based available in artificial intelligence. Okay, we have declarative knowledge, which will be work based on the facts, and we have procedural knowledge. Here it takes how to do things. It takes data and it will only come to a conclusion on how to do things. Heuristic knowledge, here we experienced it takes experience from the past cycles which have been done in the process. Okay, and then meta knowledge, it is the knowledge about knowledge. The knowledge will take it from the knowledge itself, where it will be stored in a meta form. Okay, and then structural knowledge, relations among concepts. And at the final we have conclusion. In this lecture we introduce the concept of representing knowledge using rules. This is very important, and we documented it efficiently. We also compared knowledge representation with traditional data structures and explored various AI specific knowledge structures. Okay, and thank you for watching, and we'll wind up the session. Thank you.